Hey everybody, this is Kai Werner from Confluent. Today I want to talk about the rise of data in motion in the insurance industry. We will explore several different use cases and architectures from real-world deployments. Let's get started. First of all, let's talk about the motivation, why the insurance industry is changing so much. So obviously here in this picture you see how the world is changing in general, but we really see that the insurance industry is on a huge shift these days. So on the one side, of course, it's going much more to online and mobile. So of course, there are still subsidiaries, right, where you can go into a branch. But on the other side, more and more of the insurances are done via online, especially the smaller ones, let's say. Maybe not the one for your house, but the one for the car maybe. So that's what, of course, you can also decide. But in general, the situation is that it's completely moving into the software world. And it's not just about the insurance itself, but also, for example, the payment. So in the US, you paid with credit card for a long time already. So in Europe, this is very new. But now even more innovative kinds of payments are possible. And some insurers even start accepting Bitcoin and other cryptocurrencies. So it's simply moving to the software world more and more instead of signing a paper and then agreeing on the payment form. Well, and then it also depends on what you want to insure. But in this case, about the vehicles, they also become software. And that's great because with that, you can also collect more and more data about the software, which is the vehicle. And then you can make a better offering around your product for insurance for that. And so we will also see a real world example for this later today, how event streaming is used here to process the data in real time. But therefore, we just need to be aware it's not just about the insurance software, but also what you want to insure. All of that is also software across industries and across products. Yeah, well, and with that then, it's not just about the insurance you provide, but really about the process of the insurance. It's all about automation. This leverages things like AI under the hood. Like when you upload a picture of your damaged car, then the AI will analyze this picture to detect if it's maybe fraud or how much the damage is, how much the value of that is. And all the communication with the insurance is often also digitalized from an insurer perspective, and often with chatbots and natural language processing so that you can really reduce the cost and hopefully also provide a better customer experience. And with these kind of discussion points, it's really clear that the traditional insurers have to change. On the one side, the insurtechs are attacking, so we will see a few examples here too. But on the other side, the traditional players, like in this example, Allianz, they are showing a lot about how they are completely changing their market. So in this case, you see where Allianz Direct, which is one of the solutions Allianz is offering now, has built a completely digital platform in a cloud-native, elastic, scalable way. And then with this, they can build new features easily in the cloud. And so they see themselves as more a technology company with an insurance license. And I think this is where really most of the traditional players are going to. You can still have branches where the people go to, but a lot of this will also happen online. And I really like the quote from the Allianz Direct CEO. So he said, one big lesson we've constantly applied is that our Allianz staff should be focused on consuming as much as possible the best external products. And I think this is the clear trend we see on the market across industries. Where possible, you consume something as a service and focus on your own business problems, on the things you want to differentiate on. And that's exactly what we will talk about today and why data in motion powered by Apache Kafka can help so much. So with this motivation about why the industry and insurance is changing, let's talk about how this works. So there's a lot of challenges the insurance industry has to solve. And of course, it's challenging market environments with a lot of competition. The traditional players, the insurtechs, third party from other verticals that is also providing insurance today. And of course, in combination with that, you have a lot of regulatory pressure and you want to have a good customer experience because otherwise they go to the competitor. But unfortunately, in conjunction with all these requirements, now many of the traditional players still have a very monolithic legacy architecture, often running a lot on mainframes and similar monolithic components that are costly, but not really elastic and agile. And so with this in mind, we see why insurance companies have to change to stay competitive and to become more innovative than in the last decades. And with this, we're talking about a fundamental paradigm shift. So everybody agrees that the cloud is a game changer about how you think about data centers. So it's more elastic, you can scale up, you can also scale down, you don't have to wait months for new hardware to build a new project. And this is what cloud native means. Even if you're not in a public cloud, but maybe running your own data centers on technologies like Kubernetes and containers, it's still elastic and flexible because it's much more virtualized than a few years ago. And in the same way, what I want to talk about today is how event streaming is the future of data. So this means that you continuously process data in motion. And this is really where the huge benefits come for the customer, but also from a revenue perspective to make better upselling or do customer-specific pricing and all these kind of things. And that's what we want to talk about today in the session. And actually, it's pretty easy why we do this. So real-time data beats slow data. If you think about that, this is true for almost every use case. There is use cases like reporting in the BI world or like model training in the AI world. So this is where it's typically still a batch process that can run overnight or can even take a few hours or days, right? And that's okay for these use cases. But for most other use cases, you get much more value out of that if you are actionable, if you act proactively on the data or at least reactive in real time instead of processing the data overnight in batch. And this is really true for almost every use case. You won't find many use cases where batch is better than real time. So here's a few examples. So it really doesn't matter what use case you're looking at, but think about the insurance examples like claim processing. Of course, if the end user uses the mobile app and all the processing is happening in real time or near real time, that's a much better process than what we have seen in the last decades, where this took hours or even days or weeks to process your claim. And there's one sub-process of that is the fraud detection example. Like if someone uploads a picture from the damaged car, you want to do a first fraud detection in real time. And maybe then you can already say, well, this doesn't look good, so let this send to one of our other business units for the fraud example. And with this in mind now, we understand that across the different use cases in the business process, real-time data beats slow data almost all the time. And therefore, we're coming to event streaming to process data in motion. An event is something that happens in your business. This can be something technical, like a sensor from the car, or this can be an insurance claim where you type something into your mobile app, or maybe on your computer into a Word document, whatever it is. It can be modern technology, it can be more traditional, it can be a technical or a business event. But the point is that the world is events, and you need to correlate this. And this is actually what's happening in every business process. Now, if you think about that, in the insurance world, if some mobile user puts some information in for an incident, then you need to act and do the claim processing. And as a third-party application, you maybe also have fraud detection integrated. And then after the claim is processed, after maybe only seconds, but maybe after days, then you do the reporting, maybe across all your customers or a region or so. These are all decoupled challenges and decoupled applications, and that's okay. But the heart of this infrastructure is a business which is a stream of events. So everything can be processed in real time where needed or where it's valuable. And then it's still okay if some of this is only batch, like the reporting in green on the right side in this example. But the heart of the infrastructure is real time to process the data in motion. And that's where Apache Kafka comes into play, which is an event streaming platform to process data in motion. So many say Kafka is a messaging platform, and actually it is, but it's much more than that. So the heart of Kafka allows you to process millions of events per second from A to B and to C. But in addition to that, it also stores the data, these events, in an event-based way. So this is very different from a database or data lake. And so in this case now, the consumer can consume the data in real time, while another consumer, like the data warehouse, consumes it in batch. Because all these systems are truly decoupled, because Kafka is a combination of messaging and storage in a scalable way. So you can use it for analytics use cases with high volumes of data, but also for transactional workloads, similarly like you do it on a mainframe, where you really care about exactly one semantics and no data loss. In addition to the storage and messaging, Kafka is also a data integration layer. You can connect to legacy systems like a mainframe, but also to modern cloud services and AI solutions. And last but not least, probably for many use cases, the most important one is that you can also process the data in real time. You can aggregate data from different systems and act on it in real time. That's called stream processing or streaming analytics. And that's what you can also do with Kafka. And with that, you see, with one single platform, you can do a lot of these kind of things, both for analytical and for transactional workloads. Here's one example architecture for that. Let's think about claim processing and fraud detection. From the left side, we get a lot of the customer events in. So this is the customer data stored in a database, maybe about a new claim you have there. And on the other side, you also integrate with your CRM system like Salesforce. And then you correlate all of the data. And as part of that, on the top right, you see that one of these applications is the fraud detection application that takes this incoming data from the different sources, correlates it, and applies an analytic model to do real-time scoring on that. And so here in this case, we're using TensorFlow for that. So that's not Kafka, right? Kafka is not machine learning, but you can embed machine learning into a Kafka application. And then on the bottom right, you see then, of course, you also connect to other sync systems, like a MongoDB database, like a Snowflake data warehouse, whatever you need to integrate with. The key piece of this architecture compared to others is that the heart of it is real-time and scalable. And this is very different from a data lake approach, where you ingest the data from all the sources into a data lake and then you store it at rest, and then someone else consumes it later and processes it. Again, this is good for reporting, or this is good for model training, but not for real-time use cases, because then the data is already at rest and then it's too late. And with Kafka and event streaming, you can correlate and process the data in motion while it's hot, while it's interesting. Yeah, and the rise of the event streaming and data in motion, well, that started actually in 2010. So Apache Kafka was open sourced at that time, was created at LinkedIn, but then gave it to the Apache community. And so then it started to be very successful across all industries. Especially after 2014, when Confluent was founded by the inventors of Kafka to make Kafka enterprise ready, to make it secure, to make it safe, to make it even better scalable and all these things. And with that now, almost every company across the globe uses Apache Kafka for different use cases. Many of them with Confluent. And this is the rise of data in motion we see here. Right? So everybody is using it. The question is just how can you use it for your different scenarios? And therefore, I want to talk about a few different real-world deployments. And intentionally, I've chosen very different kinds of use cases. So you see the broad spectrum about things that are done with Kafka and its ecosystem. The first example is from Generali. So this is a traditional integration problem where Generali and many other people or companies choose Kafka as integration layer instead of other ETL tools or ESBs or MQ systems, because it combines these unique characteristics of being scalable and real-time at the same time. And so here you see that Generali is connecting to many core systems. So they have hundreds of different databases from different vendors. And this is where their critical workloads are running. So they cannot shut it down from today to tomorrow. But they needed to integrate that with their modern applications running in a microservice architecture. And so for this reason, Generali chose the Confluent platform to do this data integration layer between many legacy systems and also the modern applications. And they are still truly decoupled with Kafka, but they communicate with each other. And that's the huge advantage of such a platform. In their case, they started already a few years ago on Kubernetes based on OpenShift and deployed Confluent to be in a cloud-native elastic way for the whole end-to-end integration. Another example is Centene. So they are using Apache Kafka as integration and data processing pipeline at scale. So the interesting use case about this is that their problem is growth, as they say, and that's a great problem. And the reason for that is that they acquire a lot of other companies every year. And with that, they need to have a continuous integration platform that needs to add more and more data sources, but also correlates it and processes it in real time at scale, and then send some data back to these systems. And therefore, they choose Kafka as a highly scalable and autonomous platform. So they are doing it not just for sending data from A to B. And that's the real value of Kafka. You can also correlate the data and process it in real time. And so on the architecture on the right side, you see that the heart of this infrastructure is Kafka for exactly this reason. This doesn't mean that Kafka is solving every problem, right? On the one side, you still need to integrate with legacy systems. Like in this case, you see the Ksql database as example. But also you integrate with other modern systems. Like on the top, you see that they also have a MongoDB cluster running where they have other use cases on top of that. But again, the heart of the infrastructure is Kafka, and with that it's real-time and scalable at the same time. But also truly decouple the different legacy and modern systems from each other. And that's a huge strength of Kafka. Swiss Mobiliar is another great example. They leverage Apache Kafka and its ecosystem as orchestration layer. So in this example, they track the state of a billing process. And therefore, they use Kafka as a database. This means it's really a durable storage for critical data. In this case, it's not analytics data, right? It's billing and it's comms. So this is data that you never should lose, and it's durable, long-term. But you can store these events in Kafka because it's not just a messaging platform. And then based on these events, they build complex stateful aggregations across contracts and recalculations. So this is really a complex, powerful system they have built with different microservices. In addition to that, they also provide continuous monitoring in real time. Because if you have the data flow in real time anyway, it's super easy to also build a real-time monitoring system on top of that. And therefore, in their case, they also leverage Kafka for the stream processing, and they use Kafka streams for that. This means, of course, you could also use another system for stream processing, like an open source tool like Flink or something like Storm or a commercial tool. That's doable the same way, and many do that with Kafka as integration layer. But if you have the Kafka system anyway, it's super easy from a development and from an operations perspective to also do the data processing with Kafka, because then you only have one platform to operate and test and monitor end to end. And this is what we see more and more in the market, that people use Kafka not just as the integration layer, but also for building applications and processing layers. The last example is from Humana. So they have built an analytics platform with Confluent. So in their case, they needed to build interoperability between many different systems. I mean, that's a problem I think every insurance company has. And the interesting part about this is, on the one side, that this is really a cutting-edge technology. So they combine event streaming together with AI. In their case, they are using Watson. So they do natural language processing with this IBM solution. And they integrate that with Kafka with the other ecosystems. So in their case, and you see this in the maturity curve they had. So they started from a batch data exchange with a lot of point-to-point integrations. And therefore that was time delayed, it was very complex. And they evolved this with a standardized interface. But the important part is that this standard interface is also real-time and scalable. And that's why Kafka is the key piece here. And with that, then over time, they got more and more mature to also provide innovative new use cases. And they now discuss more things like real-time patient interactions or near real-time access to expensive clinical data. And that's the things where you often start small with combining a real-time pipeline with existing legacy and batch systems. And then over time, you can build more and more new applications around that. Because the heart of it is real-time and scalable, but also powered by an open standard, and it's interoperable, no matter what technology you use in your systems. And therefore, I think Humana is a great example. Freeu is an insurtech. So this is not a traditional player, but started relatively fresh, and therefore they could start from the green field. And for that reason, what they are doing is they have built an infrastructure on top of Kafka with Ksql to do real-time streaming analytics by consuming data from different systems, and then calculating prices in real time and do real-time price adjustments. In their case, it's about vehicle insurance, and not so much about cars, but also about bikes, for example. Like you see in this picture. For example, I live in Germany, and when I go to Austria for a week into the mountains, then I want to insure my bike for that week, and maybe also myself. It also depends on what you have already. But here then, you get a context-specific offering. And this can be based on your customer information, like the loyalty system. But this can also be based on external systems like the weather. And with that, your risk engine can calculate, hey, if it's snowing all day long, then it's a little bit more risky, so maybe we should charge a little bit more here. And that's what they have built in real time to make automatic price adjustments based on the context, both from the customer side, but also from external factors for that. And so I think this is really a super interesting use case where it shows that a streaming platform provides this added value here, because it all happens in real time and not in a batch process overnight. Because if you also integrate like the weather information in real time, well, that doesn't work overnight. You need to know how much snow is coming in the next 20 minutes and not in 2 days. And the last example I want to show is Tesla. So now many people want to say, well, this is a car maker, and maybe some are aware that this is also a huge utility company about their energy business and storage and so on. And that's true, actually. And with that, Tesla processes trillions of messages per day for IoT use cases with Kafka and its ecosystem. So I talked a lot about that in my automotive and energy talks, right? So and then there's also the links from the Kafka Summit. You can listen to that in more detail. The interesting part I want to mention here is that actually Tesla is going into the insurance business. And that's what many people didn't know. But as Elon Musk said one time, much better feedback loop is what you have with Tesla, because all the cars are connected. You're collecting a lot of sensor data in real time. And with that, you don't be a statistical player like the others that have very old and legacy batch processes to calculate insurance prices. No. Instead of that, the pricing can be based on the driving behavior in real time. And with that, you have a much better risk estimation, and also for repair cost of the vehicles. And all these kind of things are much easier if you have this real-time pipeline. And therefore, this is a great example where probably Tesla hasn't built this real-time pipeline for the connected cars and for their energy power packs and so on, for the insurance use case. But now where they have this infrastructure, well, you can easily build new use cases. And in this case, Tesla, the auto car maker and the energy company, is now moving into the insurance business to compete with other car insurers. And I think this is also the key piece of Kafka, right? You have the central data pipeline running once in real time, and then a new consumer, like a insurance application, can consume the same data, but correlate it in different ways for a different use case. In this case, what's the pricing for the insurance for our customers? And with that, I want to talk a little bit more about the technology after we've seen a lot of use cases across the different scenarios. I said it several times already, Kafka is unique because it's a combination of messaging, publish, subscribe at scale, but also a durable system that stores the data continuously in a durable way, reliably, similarly to a database. It stores it as events. And then you can also integrate with other systems and process and correlate all of the data. All of that is Kafka, right? So you don't need another system for that together with Kafka. And with that, you can make your business real time. And that's truly what it is. So in this case, we're using Ksql so that you only write SQL queries and deploy them to the production cluster. But the point really is no matter where the data comes from. This can include legacy systems like a mainframe. But then you can correlate all of the data just with Kafka technology. And this is the beautiful part. You can connect to many systems, but then also correlate all of the data in real time. And with that, you can build this kind of central nervous system to provide your business a stream of events. As we've seen in the example before, this is typically very different applications with different technologies. Like the claim processing might still run on the mainframe, and it's totally okay if it runs there and it's still good for you. But then maybe the fraud detection application is something running in a more modern way, trained in the cloud and then deployed in a Java application in your data center. It's totally up to you how this architecture is. It's open and flexible. But again, the key difference is that the heart of it is real-time and scalable because it's powered by Kafka. And this is very different from a data lake approach where you store the data at rest. Because then for many use cases, it's too late regarding risk or revenue or regarding customer experience. So now people ask, why can't I do this with my existing data platforms? This is a very valid question, and I discuss this every week with customers. So let's take a look at that. And once again, I'm repeating myself, but Kafka is unique because it's a combination of messaging at scale, storage, data processing, and data integration. And this combination makes it so different from all these ETL tools and message queues. Therefore, here you see a comparison where you see how these characteristics play together if you have them all in one platform with event streaming. And I'm not saying don't use a database anymore, so don't get me wrong. If you want to store data long-term and do a few complex queries on that, then it's still a traditional Oracle or MySQL database. If you want to have document stores, then it's a MongoDB. That's totally fine, right? And for reporting and analytics, the data is still in a data warehouse typically. That's totally okay. But the key piece is that event streaming, you can combine all of these characteristics to provide an event-driven transformation. The heart of it is real-time and scalable. Almost all of our customers still use Kafka to also integrate to a data warehouse. That's totally okay, not the point. The point is that the heart of the infrastructure is real-time and scalable. And then you can also combine it with these other technologies. Again, if your microservice needs to store data long-term and you need to do complex SQL queries, then your microservice should probably have a traditional database behind it. But that's then just one producer and consumer to Kafka and truly decoupled from others. And therefore, I really cannot emphasize this enough. So Kafka or Confluent, we're not solving every problem, right? But the heart of the infrastructure is real-time and scalable. And you can build new business applications with transactional workloads and use analytic workloads with Kafka. But of course, you can also combine it with all your other existing systems. Like on the left side, if you want to integrate to a mainframe, many of our customers do this via our IBM MQ connector. Or you directly connect to the DB2. Or maybe you're using IBM IIDR or some other third-party tool to integrate this tool. That's totally fine. It's complementary. And the same on the right side. If you want to provide an API layer on top of your real-time data, then you use an API management platform, right? In this case, it's MuleSoft Anypoint here. So that doesn't matter what it is. It's complementary. That's not Kafka. But you can combine it very well. On top of your real-time streaming layer, you can provide APIs, in this case with MuleSoft Anypoint, and provide it to the external world then. So you are very flexible with your architecture. Let's now take a look at two examples. The first one is about mainframe offloading. For every insurer that's older than 10 years, they probably have mainframes running, right? And running their mission-critical workloads on. But the problem is it's very costly. And in addition to that also, you often don't find people anymore that can change or write COBOL code and so on. And so one great example for this is the Royal Bank of Canada. So they are using Confluent to offload data from the mainframe. And with this, they can save millions of dollars just by offloading data. This means you're not shutting down the mainframe because it's still running the mission critical systems, some of them. But you offload changes from the DB2 on the mainframe into Kafka, and from here you can connect to the rest of the world without relying on the mainframe as an integration layer. And with this you can reduce the costs a lot and build new applications with innovative technology. In most cases, when we talk about mainframe integration, we are talking about the Strangler design pattern. And I think this picture is obvious, right? You start with the mainframe, and then you build a new application with another technology, and then you build new applications and more new applications, and maybe you also migrate old applications from the mainframe to the new technology. And then over time, you might shut down the mainframe completely, or maybe not. That's up to you. So here's an example of that. Here is the year 0. This is today, and we still have a lot of mainframe applications. They directly connect to the core banking platform, for example, which is often a few decades old regarding the code. And so it's not agile and elastic, what you should be today to be competitive. So in this case now, we're doing the mainframe offloading. This means while the mission-critical workload is still running on the mainframe, we are pushing changes into Kafka. And so the event is stored in Kafka then. And from here, every other application can consume it without paying MIPS or MSU. And then over time, you can build more and more new applications. This can be Kafka native applications with Ksql, for example. Or this can be other technologies, like in the cloud, where you use Elasticsearch or a cloud native AWS service for that. And you can even do this bidirectionally. So you can also send data back from the cloud into the mainframe with such an integration layer, of course. But then over time, well, you might even be able to shut down the mainframe. Maybe just for a specific application that you have re-engineered in the cloud, or maybe for the complete system. That's once again up to you and your strategy. And often it's not just about 5 years, but this is more a 10 or even 20-year journey you have to plan. But again, it's the flexibility here. Build new things while connecting to the old things in a way that you need to, including the migration if it makes sense. The second example is about fraud detection. So here we see an example from PayPal where they leverage Apache Kafka to process billions of messages in real time for doing fraud detection. And as you can imagine, this is a super complex architecture. It's not just training one model and then deploying that to do the fraud detection. This is really a very complex orchestration layer in the end, so that you can leverage different models and statistics and then act based on that. So it's really a complex thing. And for this integration and orchestration layer and for running these transactional workloads, this is where Kafka comes into play here. So this is super interesting, and Feel free to take a look at all the content on the web about PayPal's fraud detection engine powered by Kafka. So if you take a look at such an architecture, it's actually pretty straightforward, because in the end you have an integration pipeline where you stream data in real time. In this example now from the insurance app, where you upload a picture, for example, and then you want to run fraud detection on that, on the picture or on the metadata or whatever. And in this case, the pipeline can already exist, and you can just add a new use case to it, like in this case in green, where we now, in addition to have all these other consumers already consuming from Kafka, we now also deploy an analytics platform that consumes the data from Kafka and then trains an analytic model with TensorFlow or any other similar service. And then we don't even build a completely new fraud detection application on the right side. We are updating our existing real-time alerting system that already exists and has some code inside. And we embed the analytic model inside that application to do real-time scoring for fraud detection in the future. And this again shows how flexible this is. You can already have running systems there in a pipeline. Like the batch platform on the bottom right, that existed already beforehand. And then you added machine learning in a new technology, also completely decoupled from that, consuming the data and training a model and then do model scoring with that. So the pipeline is very general, right? So in this case, we integrate, for example, for payment app, or in this case, what I'm also often seeing is that we have a Kafka cluster that runs the mission critical workloads. In this case, the bottom left. And then we have a specific analytics cluster, maybe somewhere else like in the cloud, while the mission critical one is running in the data center. And there then we do our model training in the cloud. So there's also Kafka native technologies to do this replication in real time between Kafka clusters. Yeah, and then we give the data to the data scientist, and the data scientist does not write Java code. And here's a great example to solve this impedance mismatch. So the data scientist always uses Python and Jupyter in 98% of cases for doing rapid prototyping of the model. And so we can use Ksql within a Jupyter notebook for that. It's Kafka native, but it's still speaking the language and technology of the data scientist. In this case, for pre-processing the data in this example. Yeah, and then we train our model. So in this case, we are directly consuming the data from Kafka and train our TensorFlow models from there. In this case, you don't even need another data lake like Hadoop or S3, because you can store the data in Kafka long-term. And especially now with tiered storage in place, this is really straightforward and still cost-efficient, because you can store terabytes or petabytes of data in Kafka, like in a data lake, with Hadoop, for example. But it's all event-based with Kafka, and from an application perspective, you don't even see this long-term storage under the hood. You just consume the data like before with no breaking changes. And then if it's new hot data, then you consume it from the broker. And if not, then you get it from the object store under the hood that you don't see as an end user. And this is perfect for model training, right? You can consume historical data from the last year directly from Kafka. You don't need another data lake for that. No additional infrastructure needed. And there is plenty of other use cases these days where you can reprocess historical events, and therefore we see more and more trends of storing data in Kafka long term. So not just for 3 days until it's ingested into a data lake. No, we store it here for long term to process it in real time on the one side in milliseconds, but also reprocess it later. And later it can be a week later, it can be a year later, it can be 5 years later. Excuse me. For example, for compliance and regulatory processing, especially in insurance, you also need to take a look at historical data about a compliance issue. And then you deploy this model, in this case of fraud detection. With Ksql, as you can see here, this is just a very simple query. The TensorFlow model is embedded into the query. And so you can do real-time scoring on millions of payments per second if you need to. All with Kafka native technology. So with this, I hope this was a good overview about different real-world deployments, and then a few examples with mainframe offloading and fraud detection to see how you can leverage event streaming and how this is a paradigm shift, similarly to the cloud for the infrastructure, but this time for how to process data. Instead of doing all of that at rest in a data lake or database, you continuously process the data. Because remember, in almost all cases, real-time beats slow data. So why are people working with us on that? Well, On the one side, this is typically a journey, right? As you have seen in the mainframe example, this is not a big bang from today to tomorrow. Same for the mainframe offloading, right? So in this case, we start early to help you give the guidance for the right architecture, bring the first pilot into production. But then you can scale it up, you can roll it out in a hybrid way, multi-region, multi-cloud, and then you can build more and more new use cases around that. So this is the general trend we see at our customer base, and we help them, of course, with the tooling and the support and the expertise. So on one slide, what are we doing in the end? I typically see Kafka as the car engine. So this means it's the open source framework, it's free, it's battle tested, and we still commit over 80% of the code to this project, right? It's super critical for us. It's the heart of our infrastructure. But you have to maintain it by yourself. You have to handle failures by yourself. You need to do the bug fixing, the benchmarks, the tuning. What we provide as Confluent platform is a complete car. This means it's safe, it's secure, the monitoring is built in and automated, the operations is built in, all of that as a complete car. And then if you're in the cloud, you're even more lucky, because in the public cloud, with Confluent Cloud, we provide a self-driving car. This is the only Kafka cloud service that is truly serverless. This means you really use consumption-based pricing and don't get access to the brokers. The performance tuning, the rolling upgrades, the security fixes, that's all things you don't have to worry about, because you get it as a truly serverless offering with consumption-based pricing and mission-critical SLAs. And that's in summary what we are doing. And we have a long list of features. This is a few of the examples, so I don't want to go into that here. The point is really that we provide the complete solution in a cloud-native way. So even if you're on-premise, we provide the elastic and scalable features so that you can, for example, run it automatically on Kubernetes. In the cloud, it's cloud-native anyway because it's truly serverless. And so we provide it everywhere. Cloud, on-prem, edge, outside the data center, hybrid, multi-cloud. You can run it as you need and also do migrations, for example, from on-prem to the cloud. And with that, I hope this was a good overview for you about event streaming with data in motion in the insurance industry. Feel free to reach out to me on LinkedIn to stay in touch, or also follow me on Twitter. And I really hope you like this and let me know your feedback. Thanks a lot for watching.